electric current are treated as scalars only. So, what is vector? Physical quantities having both magnitude and direction and obey laws of vector addition. Obey laws of vector addition that are treated as what? Vectors. Okay. If the physical quantities having both magnitude and direction and does not obey laws of vector addition that are treated as what? Scalars. Examples. What are examples? Electric current and speed of light. And also here, so in case of vectors, here vectors simply we can't add. Why? Vectors having both magnitude and direction. Vectors having both magnitude and direction. So, simply we can't add by using ordinary algebra. We follow vector algebra in this. So, basically we have now we discuss first of all types of vectors, and before that how we represent vector? Vector quantity represent by arrow. Now, length of the arrow proportional to what? Magnitude of vector quantity. Now, A is initial point, B is equal to what? Terminal point. Now, head of the arrow indicates what? Direction. Here length of the arrow proportional to what? Magnitude of vector quantity. A length of the arrow is more, magnitude of vector quantity is more, like that. Now, head of the arrow indicates what? Direction. And also how you represent vector? Here suppose displacement S bar, velocity V bar, acceleration A bar, like that. Now, like that. And also now we discuss types of vectors. So, first of all we have null vector. What is null vector? A vector having a vector having 0 magnitude, a vector whose magnitude is 0, that is called what? Null vector. A vector whose magnitude is 0 is called what? Null vector. Next we have, now a simple example, a particle moves in a circular path, a particle moves in a circular path. So, it starts from A and it completes one complete rotation. Displacement how much here? Displacement is 0. What is displacement? Shortest distance between initial point and final point. Here particle starts from A, it travels along the path, a circular path of radius r, it completes one complete rotation. It completes one complete rotation. Displacement how much? S bar is equal to 0. It is example of null vector. It is example of null vector. If a particle completes one rotation, displacement how much? 0. Distance how much? 2 pi r. Distance is 2 pi r. What is distance? Length of actual path travelled by the body. Length of actual path travelled by the body. So, it is nothing but what? Circumference. Circumference or perimeter. Distance is 2 pi r. Displacement how much? 0. It is example of displacement is 0. It is example of what? Null vector, like that. And also next we have unit vector. Unit vector. What is unit vector? Unit vector. Unit vector. A vector whose magnitude is 1. A vector whose magnitude is 1 is called what? Whose magnitude is 1 is called what? Unit vector. What is the use of unit vector? It is used to specify the direction. We have conceptual question. Unit vector specifies use of unit vector. Unit vector specifies the direction of vector quantity. Unit vector specifies the direction of vector quantity. Suppose A bar is a vector. A bar is a vector. What is its magnitude? Modulus of A bar. Now, what is direction of A bar? Now, unit vector in the direction of A bar. Unit vector in the direction of A bar how much? A cap. A cap is equal to what? A bar by modulus of A bar. A cap is equal to what? A bar by modulus of A bar. Now, what is A cap? It is the unit vector in the direction of A bar. Otherwise, what we understand? It is the direction of A bar. Now, A bar is equal to what we write? A bar is equal to modulus of A bar into A cap. Any vector can be read as what? Product of magnitude of vector and unit vector in the direction of that vector. Unit vector in the direction of that vector. Now, so anyhow, unit vector specify the direction of vector quantity. The direction of vector quantity. We write unit vector. Suppose r bar is a vector. What is the direction of r bar? R bar by modulus of r bar. What is r cap? R cap is the unit vector in the direction of A bar. What is A cap here? A cap is the unit vector along A bar. Unit vector along A bar, like that. Now, basically we have 3 unit vectors. Basically we have 3 unit vectors. What are that? Now, in Cartesian coordinate system, now x axis, y axis, z axis. Now, I cap, j cap, k cap. I cap, j cap, k cap are unit vectors along x, y, z axis. I cap, j cap, k cap are unit vectors along x, y, z axis. Now, modulus of I cap is equal to modulus of j cap is equal to modulus of k cap is equal to what? 1. modulus of k cap is equal to what? 1. Here always unit vector means what? A vector whose magnitude is unity 1, that is called what? Unit vector. What is the use of unit vector? It is used to specify the direction. How? Suppose a particle moves 2 meters along x axis. What is displacement? We write like this, 2 meters along x axis, 2 meters along x axis. Now instead of along x axis, what we write? 2 cap meters. A particle moves 2 meters along x axis. So I cap represents what? Along x axis. A particle moves 2 meters along x axis. How we represent here? 2 cap meters. 2 cap represents what? 2 meters along x axis. Otherwise, if a particle moves 3 meters along y axis, what we write? 3 cap, 3 cap, like that. This is unit vector. What is unit vector? A vector whose magnitude is 1, unity. What is use of unit vector? It is used to specify the direction. It is used to specify the direction. Next we have position vector. Suppose let P be a point in Cartesian coordinate system. It has coordinates x, y, z. X, y, z. What is position vector? Let the particle is at point P. Let the particle is at point P. Now what is position vector? Line joining the origin to the point P. Now if the particle is at Q, what is position vector? OQ. OQ is the position vector. OP be the position vector. Position vector of P. What is position vector? It describes the state and position of a particle. It is used to locate the particle in space. How? With respect to the origin. What is origin here? Reference. Now position vector helps to what? Locate the particle in space. Position vector helps to locate the particle in space. Now line joining the origin to the position of a particle, that only position vector. Let it be r bar. Now OP bar is equal to what? R bar. R bar is equal to what we write? xi cap plus yj cap plus zk cap. What are x, y, z? X, y, z are coordinates. X, y, z are coordinates. What is magnitude of r bar? Magnitude of r bar is equal to under root of x square plus y square plus z square. Now unit vector in the direction of r bar how much? R cap. R cap is equal to what? R bar by modulus of r bar. R cap is equal to what? R bar by modulus of r bar. Now what is r cap? R cap is the unit vector along r bar. Unit vector along r bar. What is modulus of r bar? It is magnitude of r bar. Magnitude of r bar how much? Under root of x square plus y square plus z square. They are giving like this. A vector 2i plus 3j plus 4k. Find the unit vector in the direction of that vector. Suppose they are giving vector. Suppose r bar is equal to 2i cap plus 3j cap plus 4k cap. Find the unit vector in the direction of r bar. In the direction of r bar. What we write? R bar by modulus of r bar. R bar this. Modulus of r bar how much? Under root of 2 square plus 3 square plus 4 square. So r bar by modulus of r bar gives what? Unit vector in the direction of r bar. Unit vector in the direction of r bar. Like that. So you remember? Now basically what are I cap, j cap, k cap? I cap, j cap, k cap are unit vectors along x, y, z axis respectively. Now what is use of position vector? Here position vector helps to what? Locate the particle in space. If the particle is at P, it has coordinates x, y, z. Position vector how much? OP bar. OP bar is equal to how much? xi plus yj plus zk, like that. And also we have, next we have different types of vectors. We read all types of vectors. And also next we have parallelogram law of vector addition. Parallelogram law of vector addition. What is that? It is applicable to what? All vector quantities. Now suppose if we want to add p bar and q bar, p bar and q bar. Now two vectors p bar and q bar acting in different directions. Now according to parallelogram law, two vectors are represented by two adjacent sides of a parallelogram. Adjacent sides of a parallelogram drawn from a point. Now then their resultant is represented. By diagonal passing through the same point, like this. Now OA, OB, OC, like this. P bar, Q bar. P bar, Q bar are two vectors. The two vectors are represented by two adjacent sides of a parallelogram drawn from a point. Theta be the angle between P bar and Q bar. Theta be the angle between P bar and Q bar. Now OC bar gives what? Resultant of OA and OB. Resultant of P bar and Q bar. Resultant of P bar and Q bar. Now, if we want to calculate magnitude of resultant, vectorially P bar plus Q bar is equal to what? R bar. P bar plus Q bar is equal to how much? R bar. Now, so what is R bar here? P bar, Q bar are adjacent sides. Now, this is P bar, this is also Q bar. Now, P bar plus Q bar is equal to how much? R bar. Now, we want to calculate magnitude of resultant. Now, we extend the side OA and drop a perpendicular CD on it. Now, this is also angle of how much? Theta only. Now, so what is magnitude of resultant? You know the derivation. Here, vectorially P bar plus Q bar is equal to what? R bar. Now, magnitude of R bar how much? Magnitude of R bar is equal to under root of P square plus Q square plus 2PQ cos theta. 2PQ cos theta. Now, here 2PQ cos theta. From this, magnitude of R bar, magnitude of resultant. What is R bar resultant? Magnitude of resultant depends on magnitude of vectors and angle between the vectors. In general, here in algebra, we are not taking the direction. Just we add. Simply we add. If we have 4 and 3, if we want to add 4 meters, 3 meters, 4 units and 3 units, we are getting 7. But in algebra, in vector algebra, not like that. Now, magnitude of resultant how much? Under root of P square plus Q square plus 2PQ cos theta. What are PQ? PQ are magnitudes of P bar and Q bar. Theta is the angle between P bar and Q bar. Theta is angle between P bar and Q bar. Now, magnitude of resultant depends on what? Magnitude of vectors and angle between the vectors. Angle between the vectors. What is the maximum value of cos? Is 1. So, for which angle cos value is maximum? For 0 degrees. So, R maximum. R maximum how much? Here theta is 0. Theta 0, cos 0 is 1. So, R becomes what? R maximum. R maximum is equal to how much? Under root of here P square plus Q square plus 2PQ cos 0 is 1 under root of P plus Q whole square. Maximum resultant how much? P plus Q. When two vectors are in same direction. Two vectors are in same direction. So, maximum resultant how much? P plus Q. And before that, here one more thing. Here resultant makes an angle alpha. Resultant makes an angle alpha. Now, what is direction of resultant here? We have direction of resultant tan alpha is equal to here q sin theta by P plus Q cos theta. Q sin theta by P plus Q cos theta. What is alpha? Angle made by the resultant with P bar, with reference to P bar. Now, tan alpha is equal to how much? Q sin theta by P plus Q cos theta. Q sin theta by P plus Q cos theta. This is direction of resultant. Now, we discuss some special cases. So, you know this, we have this derivation. So, directly I explain now. You remember what is that? Magnitude of resultant how much? Under root of P square plus Q square plus 2PQ cos theta. We have concepts, we have question like this. In parallelogram law of vector addition, magnitude of resultant depends. Magnitude of vectors, angle between the vectors, and also magnitude of vectors and angle between the vectors, none of this. What is the answer now? Here magnitude of resultant depends on magnitude of vectors and angle between the vectors, like that. Direction of resultant, here resultant makes an angle alpha with P bar. So, with reference to the P bar, now alpha, what is alpha? Alpha gives what? Direction of resultant. Now, tan alpha is equal to how much? Q sin theta by P plus Q cos theta. Q sin theta by P plus Q cos theta. This alpha gives what? Direction of resultant. Direction of resultant. Now, discuss special cases. Now, here first of all, two vectors are in same direction. Two vectors are in same direction. Same direction means what? Like this. Case 1. Now, P bar, Q bar. What is the angle between these two? 0 degrees. Theta is 0, cos 0 is 1. Now, R is equal to how much we are getting? R maximum. R maximum how much? We substitute in that formula, we are getting P plus Q. So, maximum resultant how much? P plus Q. And also we are getting alpha is equal to 0 degrees. Alpha is equal to 0 degrees. Means what? Resultant will be along the same line. So, maximum resultant how much? P plus Q. What is the physical interpretation? Two vectors are in same direction. Magnitude of resultant is equal to what? Sum of magnitudes of two vectors. Sum of magnitudes of two vectors. Now, what are vectors? Now, vector means what? We have displacement, velocity, acceleration, force, like that, momentum. it is applicable to all vectors. In electricity, we have intensity of electric field is vector, magnetic induction field is vector, like that. Suppose two forces acting on a body in same direction, what we do? Just we take addition. Just we take addition. When? If two forces acting on a body in same direction. So, just we take addition. Alpha is 0. Case 2. Now, two vectors are opposite in direction. Two vectors are opposite in direction. Cos 180. Theta how much? 180. Cos 180 how much? Minus 1. Minus 1. R minimum. What is the minimum value of cos? Minus 1. R minimum how much here? R minimum. We substitute theta is equal to 180 in that equation. What is that equation? R is equal to under root of p square plus q square plus 2pq cos theta. We are getting R is equal to what? P minus q. Means what? Here what we take? Two vectors are opposite in direction. Magnitude of resultant is equal to what? Difference of magnitudes of two vectors. Difference of magnitudes of two vectors. Again we are getting alpha is 0. Now magnitude of resultant is equal to what? Difference of magnitudes of two vectors, and direction, here direction of resultant is along the direction of vector of greater magnitude. Direction of resultant is along the vector of what? Greater magnitude. If p is greater, how much? What we are taking? P minus q. If q is greater, q minus p, like that. Minimum value, so it is the minimum resultant. Why? Cos is minimum for 180 degrees. Cos is minimum for 180 degrees. So, this is the minimum resultant P minus q, maximum resultant how much? P plus q, like that. And if you take theta is 90 degrees, theta is 90 degrees. Two vectors are acting in perpendicular directions, like this, P bar and Q bar, 90 degrees, theta 90. Now, R how much? R is equal to under root of P square plus Q square, cos 90 is 0, cos 90 is 0, like that. So, what we understand here, suppose in scalar sum, what we do? Algebraic sum, 4 plus 3, 7. But here 4 bar, 3 bar. Suppose we have 4 and 3. What is the maximum resultant? 4 plus 3, 7. Minimum resultant 4 minus 3. So, resultant value lies between what? 1 to 7. Resultant value lies between 1 to 7. Minimum is 4 minus 3. Maximum how much? 4 plus 3. If you take a perpendicular, 4 square plus 3 square, 16 plus 9, root 25, how much? 5. So, 5 lies between 1 to 7. So, you must remember, in case of vector addition depends on what? Magnitude of resultant depends on what? Magnitude of vectors and angle between the vectors. Because of that, here if you want to add 4 bar and 3 bar, resultant value lies between 1 to 7. Resultant value lies between 1 to 7. Here we have question, they are giving question like that. Which are the following set of forces to keep the body in equilibrium? So, on that time we check now. Out of 3 forces, now, so resultant value always lies between what? Maximum and minimum. Maximum and minimum. Like that you remember. Here maximum resultant how much? P plus Q. Minimum resultant how much? P minus Q. Is it clear? 4 bar, 3 bar. If you want to add 4 bar and 3 bar, maximum resultant how much? 4 plus 3, 7. Minimum resultant how much? 4 minus 3, 1. So, resultant value lies between what? 1 to 7. That is the main difference between scalar addition and vector addition. In scalars, algebraic sum, just we take 4 plus 3 or 4 minus 3. Here, but in vector addition, if you want to add 4 plus 3, 7 only. But in vector addition, what we are getting? Resultant value lies between 1 to 7. Why? We are considering angle between the vectors. Now, this parallelogram law of vector addition is applicable to all vectors. Is applicable to what? All vectors. While calculating resultant velocity, resultant acceleration, resultant momentum, resultant electric field, resultant magnetic induction field, whatever it may be, it is applicable to all vector quantities, like that. Next one. And also we have components of a vector. We have one question. A vector is resolved into components. They are giving 2, 3, infinite, none of this. We have a question like this. So, what is component? Component means what? Part of a vector. Here, simple thing like this. Suppose A bar is a vector. A bar is a vector. It makes an angle theta with x axis. Theta with x axis. Now, what is component? Here, component is nothing but what? Part of a vector. Otherwise, we have like this. Suppose OR be a vector A bar. Now, projection of OR on x axis is OP. Projection of OR on y axis is OQ. OP and OQ are the components of OR. OP and OQ are the components of OR. So, vectorially what we write? OP bar plus PR bar. OP bar plus PR bar is equal to what? OR bar. OP bar plus PR bar is equal to what? OR bar. Means what? A bar is divided into like this. So, AX bar plus AY bar is equal to what? A bar. AX bar plus AY bar is equal to what? A bar. So, A bar is divided into, in a plane, A bar is divided into what? Two parts, AX bar and AY bar. What are these? Vector components. Here, what is component? Projection of a vector along any line. So, the projection of R on x-axis is OP, projection of R on y-axis is OQ. OP and OQ are components of OR. OP and OQ are components of OR. OR or PR, like that. Okay. Now, in a plane is vector is resolved into two components. So, what is component? What we understand? It is a part of vector. Here A bar is divided into our two parts, AX bar and AY bar. A bar is divided into how many parts? Two parts, AX bar and AY bar. Now, here vector, in a plane, vector is resolved into how many parts? Two parts. In a space, vector is resolved into how many components? Three components, like that. So, you know that in a plane, a particle, if a particle is in a plane, it has how many coordinates? Two coordinates. So, like that. Vector also same thing. Vector is resolved into two components in a plane, three components in a space, Cartesian coordinate system. But in general, vector is resolved into infinite number of components. We have a question like this. A vector is resolved into components. In general, so they are giving options 2, 3, infinite, none of this. What is the answer? Infinite. Where 2 in a plane? Where 3 in space? How? Vector is resolved into infinite number of components. Simple example. So, we have carom board. In carom board, we have striker and coins. Here we are giving a small push on the striker. Push is nothing but force. Striker strikes the coins. So, different coins will move in different directions. So, applied force is 1. So, but striker strikes the coins. So, different coins will move in different directions. So, what happened here? Force is divided into how many parts? Number of parts. So, that is why, how we are saying different coins will move in different directions. That is why force is divided into how many components? How many parts? Infinite number of parts. That is why, in general, vector is resolved into infinite number of components. We have a question. Is it clear? What is question? A vector is resolved into components. They did not mention plane or space. So, in general, what we are taking? In a plane, how many components? 2, space 3. But in general, vector is resolved into how many components? Infinite number of components. Infinite number of components. So, now, any vector can be read as what? Product of its magnitude and unit vector. Ax bar, what we write? Ax into I cap. Ay bar how much? Ay into j cap. Ay into j cap. What is magnitude of A bar? Magnitude of A bar is equal to under root of Ax square plus Ay square. Ax square plus Ay square. So, this is magnitude of vector. Now, cos theta how much? Cos theta is equal to in triangle OPR. Cos theta is equal to Ax by A. Now, cos theta is equal to in triangle OPR. So, cos theta is equal to Ax by A. So, Ax is equal to how much? A cos theta. Ax is equal to A cos theta, where? In triangle OPR. In triangle OPR, cos theta how much? Ax by A. Ax is equal to how much? A cos theta. Sin theta how much? Sin theta is equal to Ay by A. Now, Ay is equal to how much? A sin theta. Ay is equal to A sin theta. Ax, Ay are components of vector. These are scalar components. A cos theta and A sin theta are scalar components. Components of a vectors are scalars. What are that? A cos theta, A sin theta. A bar is a vector. Now, A cos theta is along x axis. It is called what? Horizontal component. A sin theta is along y axis. It is called what? Vertical component. Now, these two are perpendicular. These two are rectangular. So, these two are perpendicular to each other. So, what we say? Rectangular components. Rectangular components. Okay. Here, it is applicable to all vectors. Initial velocity u bar. What is the horizontal component? U cos theta. What is vertical component? U sin theta. Like that. So, and direction of vector. Direction of vector how much here? Tan theta is equal to how much we are getting? Tan theta is equal to Ay by Ax. Tan theta is equal to Ay by Ax. So, what is theta? Angle made by the vector with x axis. So, by using this, we calculate direction of vector like that. And also, so anyhow A bar is a vector. What are components here? A cos theta, it makes an angle theta with x axis. So along that x axis, how much we are getting? A cos theta, and along y axis A sin theta. A sin theta is the vertical component, A cos theta is the horizontal component, like that. We have a simple question here. If the horizontal component of a vector is equal to a vertical component of a vector, what is the angle made by the vector? Question like this. Horizontal component of a vector is equal to vertical component. What is the horizontal component? A cos theta. Vertical component how much? A sin theta. These two are equal. What is the angle made by the vector? How much here? Ax is equal to A cos theta, Ay is equal to what? A sin theta. Now, what we are getting? For which angle? Cos theta is equal to sin theta. Cos theta is equal to sin theta. What do we write now? Tan theta is equal to 1. For which angle? Tan value 1? 45 degrees. So, tan theta is equal to tan 45. Now, theta how much? 45 degrees. Like that they will ask question. Understand question? If the horizontal component of a vector is equal to vertical component of a vector, what is the angle made by the vector? How much? 45 degrees. Like that they are giving options. Okay. Next one, we have direction cosines. We have direction cosines. Is it clear? In a plane, vector is resolved into how many components? 2 components. Okay. What are that? Here, what we write now? A bar is equal to Ax I cap plus A by j cap. Ax how much? A cos theta. Ay how much? A sin theta. So, A bar is equal to, we write like this. A cos theta I cap plus A sin theta j cap. A cos theta I cap plus A sin theta j cap. So, we write like this. Okay. Next, we have direction cosines. Direction cosines. Direction cosines. Here in a space, in Cartesian coordinate system, in a space, A bar is a vector. A bar is a vector. It makes an angle alpha, beta, gamma with x, y, z axis. Alpha, beta, gamma with x, y, z axis. Then cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma are called what? Direction cosines. Now in vector, a vector in a space, it is resolved into how many components here? Ax I cap plus Ay j cap, 3 components. Ax I cap plus Ay j cap, Az k cap, like that. Now, suppose this is Ax, Ay, Az. A bar is equal to what we write? Ax I cap plus Ay j cap plus Az k cap. Az k cap. Now, here cos alpha. What are alpha, beta, gamma? Alpha, beta, gamma are the angles made by the vector with x, y, z axis. Cos alpha is equal to what we write? Cos alpha is equal to Ax by A. Cos alpha is equal to Ax by A. This is L. Let it be L. Now M. M is equal to what we write? Cos beta. Cos beta is equal to what? Ay by A. N. N is equal to what? Cos gamma. Cos gamma is equal to what? Az by A. Okay. Now cos alpha, cos beta, cos gamma are called what? Direction cosines. Vector A bar. A bar makes an angle alpha, beta, gamma with x, y, z axis. Then cos alpha, cos beta, cos gamma are called what? Direction cosines. Direction cosines. Now, here, what is magnitude of A bar? Under root of ax square plus ay square plus az square. So, on that time we are getting L square plus m square plus n square is equal to what? 1. Now, what we are getting? Cos square alpha plus cos square beta plus cos square gamma is equal to what? 1. Like that. You remember this. Cos alpha, cos beta, cos gamma are direction cosines. What we are getting? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. And also, how they are asking question? Alpha, beta, gamma are the angles made by the vector x, y, z axis. What is the value of sin square alpha plus sin square beta plus sin square gamma? Here, how much we have? Cos square alpha plus cos square beta plus cos square gamma is 1. Now, sin square alpha plus sin square beta plus sin square gamma how much? Sin square alpha plus sin square beta plus sin square gamma is equal to 2. How? Sin square alpha how much? 1 minus cos square alpha. Sin square beta 1 minus cos square beta. Sin square gamma 1 minus cos square gamma. 1 plus 1 plus 1 3. 3 minus cos square alpha plus cos square beta plus cos square gamma. 3 minus 1 how much? 2. Like that. Okay. Here LMN are the direction cosines. LMN are the direction cosines. Then what are alpha, beta, gamma? alpha, beta, gamma are the angles made by the vector with x, y, z axis. They are giving vector like this. A bar is equal to 6i plus 3j plus 2k. Find the angle made by the vector with x axis. Find the angle made by the vector with x axis. Ax value of 6. What is magnitude of a bar? Under root of 6 square plus 3 square plus 2 square. Cos alpha how much? Ax by mod a. Ax by mod a. Cos alpha is equal to how much? They are asking find the angle made by the vector with x axis. Cos alpha is equal to what by formula? Ax by mod a. Ax by mod a. Ax how much? 6. Mod a how much? Under root of 6 square plus 3 square. 36 plus 9 plus 4. How much? 36 plus 9, 49. 6 by 7. Alpha is equal to what? Cos inverse of 6 by 7. Cos inverse of 6 by 7. Like that type of problems they will ask. Is it clear? What are alpha, beta, gamma? Alpha, beta, gamma are the angles made by the vector with x, y, z axis. X, y, z axis. Like that. Next one. We have some problems on resolution of vector, already explained here, components of a vector. Now, how they are asking problems? Here we have a resolution of vector like this. Now, suppose if the system is in equilibrium, like this. Like this. Here 6 newtons, 10 newtons, 6 newtons, 10 newtons and P. And also they are giving cos 53 is 3 by 5. Cos 53, this is 53. We have question, if the system is in equilibrium, cos 53 is 3 by 5. Cos 53 is 3 by 5. If the system is in equilibrium, cos 53 is 3 by 5, then the value of P, like that. System is in equilibrium, find the value of P. So, equilibrium is what? Resultant force is 0. What force is acting here? 3 forces. What are that? 10 newtons, 6 newtons and P. System is in equilibrium, what is the value of P? Like that they are asking question. So, what we write now? Here it makes an angle, 10 newtons makes an angle 53 with y axis. This is we are taking origin. Now, what we do now? This is x axis. 10 newtons. 10 newtons makes an angle what? 53 with y axis. So, 10 newtons is resolved into what? 2 components. What we are getting? 10 cos 53. 10 cos 53 and 10 sin 53. 10 cos 53 and 10 sin 53. What we write now? Here we have 3 forces, F1, F2, F3. F1, F2, F3. First of all, what is given? System is in equilibrium. Find the value of P. So, system is in equilibrium is what? Resultant force is 0. F resultant is equal to 0. Equilibrium is what? Resultant force is 0. What force acting here? 3 forces. F1 bar. F1 bar what we write now? 10 sin 53. 10 sin 53 I cap. And 10 cos 53. 10 cos 53 J cap. Like this. Now, 10 sin 53 how much? F1 bar is equal to 10. Cos 53 3 by 5. Sin 53 how much? 4 by 5. Now, sin 53 is 3 by 5. Cos 53 how much? How much? 4 by 5. How? 3 by 5. Like this. 53 3 by 5. This becomes what? 4. So, sin 53 how much? Sin 53 is 4 by 5. Now 10 into 4 by 5 I cap plus 10 into cos 53. Cos 53 how much? 3 by 5 j cap, like this. 5 1s, 5 2s, 5 1s, 5 2s. How much? F1 bar is equal to force 8I plus 6j. This is F1 bar. F2 bar how much? F2 bar how much? 6 newtons along y axis. Along y axis which unit vector there? J cap. So 6j cap. 6j cap. F3 bar how much? P bar only. Now system is in equilibrium. System is in equilibrium. So net force how much? 0. F resultant is 0. F resultant is 0. We substitute now. F resultant is equal to how much here? F1 bar plus F2 bar plus F3 bar. F1 bar plus F2 bar plus F3 bar is equal to 0. We substitute like this. F1 bar how much? 8I plus 6j. F2 bar how much? 6j bar. F3 bar, P bar, like this. Now P bar is equal to what we write now? Minus 8I. Minus 8I. Here, how much? 6j plus 6j, 12j, minus 20j, minus 20j. Magnitude, this is vector, P bar vector. Magnitude of much? Under root of, magnitude of P bar is equal to under root of 8 square, minus 8 square how much? 64, 12 square 144. How much? Here, magnitude of P bar, how much here? Minus 108, 208. Magnitude of P bar how much? Root of 208. They are giving option like this, 208. And here what is P bar? P bar is vector. Magnitude of P bar how much? Root of 208. Root of 208, like that. Is it clear? And also sometimes you write in vector notation. Understand this question? What is given? If the system is in equilibrium, find the value of P bar. They are giving diagram like this. What force acting? 10 newtons, 6 newtons, P bar. Now 10 newtons makes an angle 53 with y axis. Now this 10 newtons is resolved into two components, 10 cos 53, 10 sin 53. So we write vector. Cos 53 is 3 by 5, cos 53 is sin 53 is 3, cos 53 is 3 by 5, sin 53 how much? 4 by 5. So we are getting F1 bar and F2 bar. It is along y axis, 6j cap, F3 how much? P bar. So system is in equilibrium means what? Net force is 0. F resultant is 0. So F1 bar plus F2 bar plus F3 bar is 0. So we calculate like this. Root of 208 is answer. So that option only correct. Like that. And also next question. Here suppose vector B bar is in second quadrant. B bar is 2 newtons. It makes an angle 30 degrees with y axis. How we write in vector? B bar vector 2 units. It makes angle 30 degrees with y axis. How we write vector? This is positive x axis, negative x axis. Positive y axis, negative y axis. How we write now? 2 bar 2 units. Suppose 2 units makes angle 30 degrees with y axis. What do we write now? What are components now? 2 cos 30, 2 cos 30 and 2 sin 30. Now B bar is equal to how much? B bar is equal to what we write? 2 cos 30, 2 cos 30 j cap, 2 cos 30 j cap plus 2 sin 30, 2 sin 30 minus I cap, 2 sin 30 minus I cap, 2 cos 30 j cap and plus 2 sin 30 minus I cap. Why we are taking minus I cap? Along positive x axis plus I cap, negative x axis minus I cap. Second quadrant, first quadrant x, y are positive, second quadrant y is positive, x is negative, like that. So B bar is equal to how much? 2 cos 30 j cap plus 2 sin 30 minus I cap. So in this way we write vector notation. Suppose if the vector is in third quadrant, both are negative, x coordinate is negative, y coordinate also negative, like that. Okay. And also, so we have different problems, so many problems. Now suppose like this, find the magnitude of OA and OB, here like this, OA BC, OA OB OC. Now R be the radius, R be the radius. suppose now, so find the magnitude of resultant of OA bar, OB bar and OC bar, OA bar and OC bar, OB bar and OC bar. How we calculate now? OA and OB are perpendicular. OA and OB are perpendicular. How much? OA how much R? OB how much R? What is the angle between these two? 90 degrees. So resultant of OA bar and OB bar how much? Resultant of OA bar and OB bar how much? Root 2. And resultant how? 90 degrees according to according to parallaxis theorem. Case 3, two vectors are perpendicular. What is magnitude of resultant? Under root of p square plus q square. So under root of r square plus r square, root of 2r square, root 2r. Now this resultant will be along OC, 45 degrees. So that's why resultant of OA, OB, OC becomes what? OA, OB. So root 2r also same direction. Now OA, OB, OC. How much? Root 2r plus r. What is that answer now? Root 2 plus 1 into r. Like this. Two vectors along same direction. What we do now? First case, we add. So what is the resultant of OA, OB, OC? Root 2 plus 1 into r. What is r? Radius of the circular path. Is it clear? What is question? Find the magnitude of resultant of OA bar, OB bar, OC bar. What is the angle between OA and OB? 90 degrees. So what we are getting? Root 2r. Root 2r is along the direction of OC. So root 2r and r is along OC, same direction. So what we do now? A resultant of OA, OB, OC becomes what? Root 2 plus 1 into r. Root 2 plus 1 into r, like that. So anyhow, before studying mechanics, first of all you must thorough vectors. Okay. Here actually what I started here, what I explained, displacement, distance and displacement. Now suppose a body is projected from the top of a tower of height h with velocity u. A body is projected from the top of a tower of height h. It reaches a height x above the tower and returns to the ground. Find the distance and displacement. Find the distance and displacement, like this. A particle or body projected from the top of a tower AB of height how much? h. Find the distance and displacement. It reaches a height x above the tower and returns to the ground. Distance how much here? Distance how much? Distance how much here? X, this is also x, this is h. Distance how much? X plus h. Distance is 2x plus h. Distance is 2x plus h. Displacement how much now? What is displacement? Shortest distance between initial point and final point. It is negligible. This is negligible. Now, what is displacement? Shortest distance between initial point and final point. Initial point and final point how much? BA. BA how much? Minus h. Displacement is minus h. AB is plus h. BA is minus h. Why? Along positive axis plus, negative axis, positive axis plus j cap, negative axis minus j cap. So displacement is BA. BA is equal to what? Minus h. Okay. Upward direction, AB is plus h. AB is plus h. So downward direction it becomes what? Minus. Otherwise we will calculate like this. Upward direction plus x minus h. So displacement how much? Minus h. Like that. One side positive, opposite side it becomes what? Negative. Is it clear? Distance traveled. Distance traveled is 2x plus h. Displacement how much? Minus h. Like that. Okay. And also here we have question. A particle moving in a circular path, it completes 2.5 rotations. It completes 2.5 rotations. Find the ratio of distance and displacement. Distance and displacement. Here particle moves in a circular path. It completes 2.5 rotations. 2.5 rotations. If the particle starts from A, it reaches A, it completes 1 rotation. Again reaches A, it completes 2 rotations. It completes 2.5 rotations. Suppose B. 2.5 rotations. Distance how much here? Particle completes how many rotations? 2.5 rotations. 2.5 rotations. 2.5 rotations. Distance how much? For 1 rotation 2 pi r. For 2 rotations 4 pi r. Now for 2.5 rotations how much? 5 pi r. For 1 rotation 2 pi r. 2 rotations 2 pi r into 2 pi r 4 pi r plus half rotation 5 pi r. Displacement how much here? displacement is equal to what? Shortest distance between initial point and final point. Is it clear? 2 end of rotations. For one rotation 2 pi r, 2 rotations 2 pi r, 2 rotations how much? 2 into 2 pi r 4 pi r plus half rotation pi r. So, distance how much? 5 pi r. Displacement how much now? Displacement is here shortest distance between initial point and final point. Displacement how much here? AB is 2r. What is the ratio of distance and displacement? Distance by displacement, S by S bar. S how much? 5 pi r by here 2r. What we are getting now? 5 pi by 2